We have one question from the chapter Similar Triangles. Question says sides AB, AC, and the median AD of a triangle ABC are respectively proportional to side PQ, PR, and the median PM of another triangle. And we have to prove these two triangles are similar. So let's say if I make a triangle here, and I'll name it as ABC. I'm making another triangle here. And let's say I name this as PQR. Is PQR? Yeah, it's a PQR. So this is A, B, C, and this is P, Q, R. Further, we are given medians here, and the medians drawn are median is the line joining the midpoint of a side with its opposite vertex. And this is also the same thing. So here, this is equal to this, and this is equal to this. So the medians are named here as per the question. It is AD, and this is PM. Now, what we have to prove is to prove that this triangle is similar to this triangle. Now, when I look into the information we have, we can see that here the sides given proportional. Let's say we are given side AB, PQ, and the side AC and PR. Now, the third information is about this side, which is not required in proving, as of now, proving the triangle similar. In fact, we need this angle, right? We need these two angles to be equal. And if I can prove these two angles as equal, we can prove the triangle similar by the property called side angle side. So what I'm doing, I'm marking this angle as 1 and say this as 2, this may be 3, and this as 4. So we are going to prove at the end 1 is equal to 2 and 3 is, 1 is equal to 3 and 2 is equal to 4. That way we can say that angle A is equal to angle P. Now for that, we need some construction here. The construction involved here is what we are going to produce this ray. We are going to produce AD to point E and say PM to this line. This is PM to point, say, N, so that this is equal to this and this is equal to this. Now, first I need to name this point. Say this is, I name it as E, and PQR, I can name it as N. And we also need to join this. Let's join these also. Now check here what you can see, what you can say about this quadrilateral. Look into this quadrilateral. What we have actually done, we have proved its diagonals bisect each other. Can you see that we have this is equal to this and this is equal to this? So we can say here this quadrilateral in which the diagonals bisect each other. So this is a parallelogram. Same here, this the diagonals bisect each other. As you can see that this is PM is equal to PN and QM is equal to QR. So this is a parallelogram. So let's the first thing that we proved here is that we proved that this is ABCE. Is it? Yeah, ABCE, and this is PRNQR parallelogram. And this reason you have to write that here the diagonals bisect each other. So if they bisect each other, now I can say that opposite sides will be equal, right? So I can write on the basis of this, I can write opposite sides. That means this would be equal to this. So I can replace AC with BE whenever I need it. And for the same reason, I can write this is equal to this. That is PR is equal to, this is PR is equal to QN. Further, you know that when two lines are parallel, like opposite sides of parallelogram are parallel, these are parallel. So on this, from here, we can say that these angles, that means by alternate interior angles, say 1, 2, 3. So I'm naming it as 5. So 5 will be equal to 2 by alternate interior angles. 5 will be equal to 2. And similarly, here I can say that angle 6, this angle 6 will be equal to angle 4. So I'll write it here again, that here, that is angle 2 is equal to angle 5, and that is angle 4 is equal to angle 6 by alternate interior angles. The reason here is alternate interior angles. Now we have proved these sides equal, and let's write down the information we had. We had AB over PQ was given equal to AC over PR and was equal to AD over PM. This was given. Now what I can do here, I can write AB as AB, PQ as PQ. I can replace AC as with what? You can see that we have proved AC is equal to BE. So I can replace this with BE and PR with QN. And what you know that if I multiply half over, it's half. No, I'm going to multiply 2 here, multiplying 2 with this. So check here, we have this thing. We have this is equal to this. So twice of this AD can be written as AE. Similarly, twice of PM can be written as PN. So that is what I'm going to do in this part. So I'll write this twice of AD as PE, and it's not P, is AE, as AE, and twice of PM as PN. Now look into this part. From here, we have proved the sides of, we actually have proved these sides of these triangles, and the other is this one. We have proved the sides of these two triangles, all three sides as proportional. So from here, I can say these two triangles will be similar. That is, from this, I can say, from here, I can say that the triangle, this triangle that is ABE is similar to triangle PQN, right? So now let's see why we have proved these two triangles similar. So for the remaining part, I'm erasing the above question here as I need space here. All right. Now, once we have proved these two triangles similar, I can write angle 1 is equal to angle 3. That's because of corresponding angles of similar triangle. And I can also write angle 5 is equal to angle 6 for the same reason, right? So I mark this as equation 1, and let's say this is 2. And the reason, as I said, these are corresponding angles of similar triangles. Now, what is 5 is equal to? 5 is equal to 2. So I'll replace 5 with 2. And 6 is equal to 4. So I can replace 6 with 4 and say I mark it equation 3. Now, next what I'm going to do is to add these two equations, that is this and this. So if I add these two equations, that is equation 1 and equation 3. Okay. So let's say on adding 1 and 3, what you'll get? I can accommodate this over here, or it's possible to write it here. So this is angle 1 plus angle 2 is equal to angle 3 plus angle 4. Now look into the figure and you can find out that angle 1 plus angle 2 is this angle A and this angle B. That's what I told you in the beginning of the question, that we are figuring out how to prove these two angles as equal. So from here, as you can see, we have angle A is equal to angle B, and I mark it as equation 4. Now I can prove the triangles similar. So we will consider the two required triangle. One was ABC, one is ABC, and the other is triangle PQR. Check here, we already had two sides proportional, that is AB upon PQ is equal to BC over QR. right? And I just proved from here, that is from fourth part, that angle A is equal to angle P. So when you look into these two triangles, let me once again show you the triangles. So we are here talking about this triangle. One is ABC and the other triangle is PQR. So if you see these two triangles, what you can figure out that here two sides, that is the sides, one is AB, that's not the side AB, over PQ is equal to side AC over PR, and the included angle here, that is angle A, is equal to angle P. So if you have done this, we can straight away write here that the triangle ABC is similar to triangle PQR, and the similarity condition is SAS. So this is what we needed to prove in this question.